right, composing functions is when we put one function inside of another. Let's see how it works. All right, there's two notations for this. You can say either that you're going to compose f of g of x, which means g of x will be the input into f, okay? Or you use this open circle, f of g of x. And when using this open circle, be careful that it's open, because a closed one would indicate multiplication, and you want to indicate composition instead. Okay, so those are the two ways we write this composition of functions. And so what happens is you're going to take the inside function, put it into the outside function as an input. So if g of x is the same as x squared, that means I'm going to go to my f of x function and put in x squared. All right, so f of x squared is the same as, why is my thing not writing? X squared plus 1. Okay, you can also do it with numbers. So we can find g of negative 2 and then put that into f. So g of negative 2 is negative 2 squared, which is 4. And then we're interested in f of 4. And f of 4 is 5. Okay, you can also go backwards. I can put f of x into g. So f of x is x plus 1. So we're finding g of x plus 1. And g of x plus 1 is x plus 1 squared. Okay, and if you were going to expand that, that would expand to x squared plus 2x plus 1. All right, or I can find f of negative 2 and put that into g. Well, f of negative 2 is a negative 2 plus 1, which is 1. So what this is saying is find g of 1. And g of 1 is 1 squared, which is 1. Okay, are f of g of negative 2 and g of f of negative 2 the same thing? No, not at all. Okay, so the order of the composition matters. So now I've got these two functions, m of x and n of x, and we're going to find the following. So we're going to take n of x and we're going to place it inside m. All right, n of x is 2x plus 1. That is going to be the input everywhere there is an x in m of x. All right, so we're going to say that m of n of x is 3 times n of x squared, which is 2x plus 1, squared, all right, minus 2x plus 1. Okay, so 2x plus 1 squared, I'm actually going to do that out here because sometimes I just need to see it. 2x plus 1, 2x plus 1, so that will equal 4x squared plus 2x plus 2x, so plus 4x plus 1. Okay, so I have 3 times 4x squared plus 4x plus 1, and then minus 2x minus 1. Are you having fun yet? I'm having a great time here. This is 12x squared plus 12x plus 3 minus 2x minus 1. Whew. So now I'm out of room. Where am I going to write this, guys? I'm going to write it right here, okay? So this would be 12x squared, 12x minus 2x is 10x, plus 3 minus 1 is plus 2. Okay, that's that one. Now we want to go backwards and we want to put m of x in to n of x. All right, this one I think will be easier. I'm also going to switch colors so we can read it. Okay, so we're going to take m of x. We're going to do this one first and then put it into there. So m of x is 3x squared minus x, and that is going to be my new input. So this is going to be 2 times 3x squared minus x plus 1. So this ends up being 6x squared minus 2x and then plus 1. Okay. If I wanted to find m of n of 2, that means I'm going to put 2 into the n function and then take that output and put that into the m function. So if I'm finding n of 2 right here, 2 times 2 plus 1, n of 2 is 5. So now I'm interested in m of 5. And m of 5 is 25 times 3, which is 75, minus 5, which is 70. Okay. This one over here, I'm going to do m of 2 first. I always do this one first, and then I take it and put it into the outside one. So m of 2 is 2 squared is 4, times 3 is 12, minus 2 is 10. So m of 2 is 10. So now I need to find n of 10. And n of 10 is 20 plus 1, right? 2 times 10 plus 1, which is 21. Ready to get crazy? I have one function and I can compose it with itself. So I can find t of x and then put that into t again. So t of x is negative 5x. T of x is negative 5 times negative 5x. All right, so that ends up being 25x. Okay, I can do it 3 times if I want. I take t of x and put it back into itself, which we just decided was 25x, and then I'm going to put it back into itself again. So I have negative 5 times 25x, which ends up being negative 125x. All right, and I could do that as many times as I wanted, but 3 seems like plenty for now. All right, and finally we can compose things off of graphs also. So first here, for part A, I'd want to find L of negative 2. Well, L is this linear function, so L of negative 2 is 3. And then I want to find E of 3. And E is this exponential function. 3 looks like right here. That output is 8. So E of L of negative 2 is 8. Okay, and we can do this as many times as we want. So first, this one, you always start on the inside and work your way out. So we're going to find E of 2 first. E of 2 is 4, right there. And so then I'm going to find L of 4. L is the line. L of 4 is 0. And then I'm going to find E of 0. And E of 0 is that exponential function, and that is 1. Okay. Finally, you can compose the same function from a graph over and over again. So you can find, let me erase my dots from the last example. You can find L of negative 4. L of negative 4 is positive 4. So then we want to find L of positive 4, which is 0. So L of 4 is 0, and then I have to put that into there. So now I'm looking for L, oops, that was an L. L of 0. And L of 0 is 2. So this final answer is 2. Okay, so you start on the inside and just keep finding that output, put that new output into the function to the left, and keep going on in that way.